So we are going to continue with the power plants, and in today's lecture, which is lecture 5, we are going to talk about the solar power plants in general. Till now we have done with the nuclear power plants and the thermal power plants. The solar power plants is also indirectly can be used in thermal power plant, or it can directly generate electricity, as we all know. So power plants in general is a larger setup, so we need to understand that a solar power plant is not something which can be set up in any location or any region. We need specific locations for that, and a lot of accessories. So a solar power plant typically will look like this, and definitely we'll need a region where there is more sunlight and sunshine shining directly on the panels at certain angles. So these kind of identifications are done initially, and after that we have the power plants set up. Sadly enough, that India doesn't have the generation of solar power on that higher level. In fact, nuclear power plant is the fifth highest generation of electricity. After that, it comes with the solar power plant. So we do need to go a long way ahead. So what does solar power plant usually consist of? It's a facility that converts the sunlight either directly like photovoltaics or indirectly like solar thermal plants into electricity. So it means that you can have a photovoltaic here, okay, and you can directly connect it to a power storage system, and then the sunlight will be received on these photovoltaics and electricity will be stored, which can actually be passed on to the household supply in the form of AC by using a power grid system. Now that's the direct use. Now indirectly it's using the solar thermal plants. Now if you remember your last classes, we have talked about thermal plants, and there we talked about heating up water and getting a lot of steam to move the turbine which is connected to the alternator to generate electricity, and basically the system basically follows the Rankine cycle. So a solar power or the solar photovoltaic is used as a source to heat that water to produce steam. So that is the indirect use. We need to be very clear with that. Now they come with a variety of flavors. That means that the solar panels that are actually connected are connected in using different techniques and different materials, which you are going to see in the later slides. Because the aim in a solar power plant, or even in any general solar panel, the aim is to increase the efficiency. So people do use a lot of different materials. Also a lot of geometry has been experimented with, out of which 3 or 4 are quite successful. So before we go to the solar power plant, let's just try to learn a bit about photovoltaics. Now a photovoltaic power plant usually uses a large area of photovoltaic cells. So you basically have this generation of electricity as soon as photons hit the panels, okay. So we have got a solar panel usually which is actually consisting of a large number of photovoltaic cells, PV or the solar cells in general. So if you look into any panel, it doesn't have an total altogether a big silicon vapor connected into it, because there are a lot of other drawbacks like the brittleness and so on. So we don't need to do that. So what usually is done is there are small wafers which are connected in series, okay, and then these will actually be connected, and the entire electricity or the electrons which are getting generated because of the photons hitting the power panels will be actually collected and then later on passed forward, okay. So this is how it is made, okay. So this entire thing will be actually a panel, okay. So this will be a panel here, and if you consider these small things, these are nothing but your cells, okay. So these are your solar cells. So it's a combination of cells that actually gives you a panel. A panel is not something which you can design. We need a lab setup, okay. We do need to laminate it and so on, okay. So if you have seen a panel before, you would see that there are a lot of mechanical fluency or mechanical testing that has been done, and it has been mechanically robust. Now this solar PV panels can convert sunlight into directly into usable electricity. In fact, even if you don't have a battery, you can actually use a solar panel. For example, if you have those car decorative items where we have the solar panel connected to it, and based on this there is a motor which actually rotates the decorative uh, thing which is there, which looks like a drum. You might have seen that, or any household power supply you can use, or you can look into even a calculator, old calculators, where there is a small panel connected to it that is a self-powered calculator which switches off on its own. Some calculator doesn't have even a switch off button. If it is not used for a long time, it switches off on its own, and then you can again switch it on and then use it, and those solar power panels work. Okay, we even have watches where there are panels, so there is like the use of direct electricity there. Now these cells are usually made from silicon alloys. To remember this term alloys, because pure silicon is used, but in order to increase the efficiency, more and more experiments are done, and we can use more and more different kind of material. So if you look into a solar panel, these are nothing but crystalline solar panel, because they are made up of crystalline silicon. If you remember the term crystalline and amorphous, okay, amorphous doesn't have a long range order. Crystalline silicon, the atoms are arranged in a long range order, and then they are called the crystalline material. Crystalline silicon might be a monocrystalline, it might be a polycrystalline, or it might be a multicrystalline. I have already discussed what is the difference between these in the last few classes. Okay, we'll look into that. Now a monocrystalline version are more efficient. Okay, we have the monocrystalline, they are more efficient, but the problem is they are expensive, okay, than the alternatives, and hence it's preferred that we use a low cost one, because we need to attain that uh, a point where we can actually have a balance between the cost and efficiency. Okay, so that's important. So it does have a good efficiency, but the cost is more. We also use something which is called as the thin film solar panels. It will basically consist of a series of films that absorb light in different parts of the electromagnetic spectrum. So what happens is, if you are considering electrons to get free from a silicon, which is usually a semiconductor having a band gap. So in case the band gap is high, and or it differentiates, or for example, let's say if we consider the electromagnetic spectrum, we have got the UV light, the visible light, the infrared light, the microwave light, and so on. So if somehow we can actually design a system that all of these lights can fall on a semiconductor, and then it will actually excite the electrons to go into the conduction band. Okay, that will be a very efficient solar panel. So what we do is we use a series of films. Different materials will absorb lights of different wavelengths and excite the electrons, because if you consider silicon, you might not have all the entire electromagnetic spectrum exciting the electrons, only a certain part of it will be used. If we can somehow use the entire part, because sun usually consists of the entire electromagnetic spectrum, we will get the efficiency to be definitely more, because the aim is to generate more and more electrons, to get more and more electrons into the conduction band from the valence band. So a thin film solar panel might actually consist of amorphous silicon, cadmium telluride. Cadmium telluride is very much used, cadmium sulfide is also very much used, but the thing is, we definitely want to get rid of these, because these are carcinogenic in nature. These are not environment friendly, neither healthy. Okay, they're cancer causing agents, so these kinds of materials are actually avoided. Copper indium deselenide, or copper indium gallium, or copper gallium deselenide are also used in the thin film solar panels. Okay, so these type of panel is ideal for applications, is very much ideal for application, and they are flexible. Now these thin films are very much flexible, so you might have seen at least in the movies, okay, even if it's not in reality, that the buildings where they are there, where panel is ideal for application as flexible films. So if you might have seen those buildings where the panels are put up and they can absorb the sunlight. Okay, so when it absorbs the sunlight, it can actually generate the electricity, and since they are thin, they can be used in different kind of structure on top of different kind of geometries. Okay, so the solar panels that we are actually using, they will tend to generate DC current with voltages up to 1500 volts. Okay, so you can generate as high as 1500 volts, but then these plants definitely need to transform the DC into AC, because we cannot transfer DC into the household supplies, because there is a lot of power loss. So in order to, if we have AC, we can transfer it over the grid system. Okay, and then the household appliances can be run using your bulb, television, and other electronic appliances. They usually have some form of a monitoring system to control and manage the plant. Okay, we do have a control system there. Okay, we do have a power plant house where everything is controlled. Look into it. In fact, the modern setup also has got the system that they can detect if there are any panels which is not working properly. Now, since these panels are connected in series, any of the panel not working will reduce the efficiency. So these kind of factors needs to be looked into. So they are directly connected to an external grid. Okay. Now, if the plant generates in excess of 500 kilowatt, they will usually employ a setup transformers. So usually if the power generated is more than 500 kilowatt, which is quite a lot, something which is called as the setup transformers are used. Okay? So these are some of the basic components that are used. Now the types of the types of concentrating solar power plants we have usually can be divided into three broadly. Okay, we have got the linear concentrating system, solar power tower, and solar dish engine systems. Okay, so what happens here is we are using a different kind of concentrators here. Okay, so what happens is if you use a concentrator, you have the sunlight getting concentrated and falling on a particular receiver, which will actually generate a lot of heat. So let's look into the linear concentrating power system. So if you look into a linear concentrating power system, it will actually collect the sun's energy using a rectangular curved U-shaped mirrors. So if you have shaped up the concentrator and in the form of U shape, it will actually allow the sunlight to fall on it when it is arranged at a certain angle, and a lot of heat will be generated. Okay, now the mirror will focus the sunlight onto a receiver. Okay, that is basically a tube that runs in the length of the mirror. So if you have this, this is basically the receiver tube. The sunlight will fall on it and will be directly directed towards the receiver. Okay, the concentrated sunlight hits a fluid through the tubes. So what is the aim? We are actually planning to have a thermal power plant here, and where sunlight is the source of generation of heat. Now this will be actually, the receiver will be actually connected somehow with the tubes where the fluid flows, might be a water or any other fluid. Okay, and this fluid is sent to heat exchange to boil the water in a conventional steam turbine generator to produce electricity. To get the alternator, basically we are using an alternator here. So this generator is connected to the alternator, and then which will basically give you the electricity. The fluid is basically sent to a heat exchanger. So you can understand that solar power will actually generate the heat, and this will actually go to the receiver, which will heat up the system, and then we will be receiving the steam to be fed into the turbine, and then finally it will produce the electricity. Okay, now there are two major types of linear accelerator systems. Okay, the parabolic system. So we have got the parabolic trough system, and we have got the linear Fresnel reflector system. Okay, so in the parabolic trough system, as you can look here, we basically have got a parabolic solar panel. Okay, and the receiver is placed somewhere here. Okay, so receiver tubes are positioned along the focal line of each parabolic mirror. Okay, so we have got the receiver there. Now in general, if you consider the linear Fresnel reflector system, one receiver tube is positioned above several mirrors to allow the mirror to great mobility in tracking the sun. So what happens is we have got the receiver here. Okay, and the parabolic or the linear Fresnel concentrating solar thermal system are placed in such positions that it will actually directly allow all the sunlight to be received by the receiver at these kind of angle. Okay, so these are the two setups which are there. This is something which is a live picture of a linear system, and this is for a parabolic system. Next we have got the solar power towers. Now solar power tower, this is the most important part, which is basically a kind of a receiver which is placed at top of a tower. So it usually uses a large field of flat sun tracking mirrors. These are basically called heliostats. Please remember this term, heliostats. You use more technical terms for writing better answers. So please remember heliostat, and it will use to reflect and concentrate sunlight onto a receiver on top of a tower. Okay, so we have the receiver at top of the tower, and we have got the panels on this, and then all of them will basically allow the sunlight to go and set into the receiver. Okay, Now this sunlight, this can concentrate, this makes it concentrated so much that it is 1500 times more compared to other solar panels. Okay, so some power towers are use water as heat transfer fluid. Okay, so it's much better. Okay, it's quite efficient and it uses water at the heat transfer fluid. Now advanced designs are there where molten nitrate salt are used because they have got a superior heat transfer capability and energy storage capability. So this might be a 1 mark objective question. Okay, why we use molten nitrate salt as a carrier of heat. Okay, so the thermal energy storage capability allows the system to produce electricity during cloudy or at night. So it does have a storage facility also, which will actually allow the system to actually generate electricity even during cloudy weather or even at the night time. And finally we have got the solar dish or engine system. Now this is more or less looks like a dish TV or a satellite dish that has been connected, that is used by you at your rooftop or actually getting out any signal. So basically it's a mirror dish similar to a very large satellite dish. To reduce the cost, these mirror dishes is usually composed of many smaller flat mirrors formed into a dish shape. Okay, so we do have a lot of mirrors here. Okay, and they are actually together joined so that actually form a dish shape. Now this dish shape surface will direct and concentrate surface onto a thermal receiver. So this is basically a thermal receiver, and this thermal receiver is connected to something which is called the Stirling engine and generator. Okay, so this Stirling engine and generator is actually nothing but the connected with the turbine which will actually generate the power, which absorbs and collects the heat and transfers it to a engine generator. Okay, so that is how this Stirling engine works. Okay, this is connected directly to the solar receiver. Okay, now a solar dish concentration ratio is much higher than a linear concentrating system, and it is a working fluid temperature higher than 1380 degree Fahrenheit. Please remember, if this temperature is high, definitely the efficiency will be more. So what we need is the sunlight that falls on a system should be able to heat up the system more and more so that we can get a higher efficient thermal power plant. That's all for today. Thank you.